For centuries, the Bohai Strait has separated northern and southern China. Now engineers are preparing to build the world's longest undersea railway tunnel beneath these waters. The Bohai Strait remains one of the busiest yet most difficult sea crossings in China. A fixed link here would dramatically change travel and trade between the two coasts. Dalian stands as the northern gateway of the project. This major port city will soon be directly connected to southern China by high-speed rail for the first time. Yantai on the southern coast has relied on slow ferries for decades. The new tunnel will turn an 8-hour sea journey into a 40-minute train ride. Traveling between Dalian and Yantai currently means either a long road detour or a lengthy ferry ride. The tunnel will create a direct high-speed rail connection. Before any tunnel can be built, engineers must thoroughly understand the seabed. Survey ships are mapping the geology hidden beneath the Bohai Strait. Core samples taken from the seabed reveal complex layers of rock and sediment. These samples help engineers design a tunnel that can safely pass through every layer. Deep boreholes are being drilled across the strait to test ground conditions. The data collected will determine exactly how the tunnel will be constructed. In Beijing, geotechnical experts analyze seismic data from the strait. Their models show the rock types and fault zones the tunnel must safely cross. China is building 4 of the largest slurry shield tunnel boring machines ever made. Each one is designed to work under the extreme pressure of the Bohai Sea. The cutter heads of these machines are fitted with hundreds of disc cutters. These will grind through hard granite while withstanding water pressure from above. Unlike the Channel Tunnel, which started from a cliff, this project must sink deep shafts through soft soil before reaching stable rock. The geology here is far more challenging than the soft chalk of the English Channel. Engineers must tunnel through hard granite and fractured zones instead. The steel shield that will protect the tunnel boring machine is being carefully fabricated. It must withstand enormous water pressure during the long undersea drive. At the northern end, a massive shaft is being sunk to launch the first tunnel boring machine. This shaft reaches deep enough to enter solid rock. Inside a dedicated factory, workers produce the concrete segments that will line the tunnel. These segments must last more than 100 years underwater. Major components of the tunnel boring machine are lowered down the launch shaft. Assembly takes place deep underground before boring can begin. At the heart of every tunnel boring machine is a giant main bearing. This precision component must rotate reliably for years under extreme conditions. The tunnel alignment has been carefully planned to stay within the best rock layers. It will run between 60 and 80 meters below the seabed for most of its length. Because of high water pressure, the tunnel boring machines will use pressurized slurry to support the face. This technology keeps the excavation stable and safe. A special plant on the surface continuously prepares and conditions the bentonite slurry. The quality of this slurry is critical to the machine's performance. After years of preparation, the moment has finally arrived. The tunnel boring machine begins its historic drive beneath the Bohai Strait. Inside the operating machine, powerful electric motors drive the cutter head. Maintenance teams work in shifts to keep the machine running smoothly. On the surface, the slurry separation plant processes the material coming out of the tunnel. Rock cuttings are removed while the slurry is cleaned and reused. Cross passages are being built between the main tunnels and the central service tunnel. These will provide emergency escape routes every 250 meters. Advanced guidance systems keep the tunnel boring machine precisely on course. Even small deviations are corrected immediately to maintain perfect alignment. Some maintenance work must be carried out under high pressure inside the excavation chamber. Special procedures and equipment protect the workers. When disc cutters wear out, they must be replaced inside the pressurized chamber. This difficult task is carried out by specially trained teams. Behind the cutter head, a robotic arm installs the concrete lining segments. Each ring is placed with millimeter accuracy to form the permanent tunnel wall. Special waterproof gaskets are fitted between every segment. These must keep seawater out for more than a century under constant pressure. The tunnel boring machine is now approaching the deepest and most critical section of the crossing. The team monitors every parameter closely. Two tunnel boring machines are advancing toward each other from opposite ends. They must meet with extraordinary precision after boring more than 60 kilometers each. When the machine encounters fractured rock, groundwater can enter the tunnel. Engineers use special grouting techniques to seal these zones quickly. When completed, this tunnel will have the longest undersea section of any railway tunnel in the world, more than twice the length of the Channel Tunnel. At such depth, natural heat from the Earth raises temperatures inside the tunnel. A powerful cooling system keeps working conditions safe and comfortable. High-speed trains create strong pressure waves inside long tunnels. Special relief ducts between the two rail tunnels will manage these pressure changes. Independent survey teams regularly check the tunnel's alignment using precision instruments. Every measurement confirms the tunnel is being built to the highest standards. The Central Service Tunnel will play a vital role during operations. It will carry utilities, provide ventilation, and serve as the main emergency escape route. Safety drills are regularly conducted to test emergency evacuation procedures. Every worker must know exactly how to respond in any situation. Once the civil works are complete, high-speed railway track is installed. China's advanced ballastless track system ensures smooth and stable train operations. The overhead electrification system is being installed throughout the tunnel. High-speed trains will draw power from this 25 kilovolt catenary. A fiber-optic linear heat detection system runs the entire length of the tunnel. It can pinpoint the exact location of any fire within seconds. After years of work, the two tunnel boring machines have finally met deep beneath the sea. This historic breakthrough connects the two coasts for the first time. Millions of cubic meters of excavated rock are being brought to the surface. Much of this material is being used to create new land along the coast. Building 4 giant tunnel boring machines and driving them under the sea is extremely expensive. Careful financial planning is essential for such a massive project. Even the most advanced machines require regular maintenance. Planned stops allow engineers to inspect and repair critical components deep inside the tunnel. The tunnel boring machines used here are significantly larger and more powerful than those used for the Channel Tunnel 30 years ago. Thousands of sensors are embedded throughout the tunnel structure. They continuously monitor stress, movement, and water pressure in real time. Until now, the only way to cross the Bohai Strait was by ferry. The new tunnel will offer a fast and reliable alternative for passengers and freight. The tunnel must safely cross an active geological fault zone. Special design features allow the structure to accommodate possible ground movement. A high-capacity fiber optic network is being installed inside the service tunnel. This will carry all communication and signaling data for the railway. At the lowest point of the tunnel, a large drainage system collects any water that enters. Powerful pumps remove this water to the surface. Workers on night shifts often rest in underground welfare facilities. These provide a safe and comfortable space far from the working face. Before opening to passengers, high-speed test trains run through the tunnel at full speed. Engineers measure pressure, noise, and vibration during these tests. A final detailed inspection of the entire tunnel is carried out before commissioning. Senior engineers walk the full length to verify every system. Excavated material from the tunnel is being used to reclaim land from the sea. This creates new usable space while solving the problem of spoil disposal. After several years of operation, inspectors confirm that the tunnel's waterproofing system is performing exactly as designed. No leakage has been detected. The final tunnel boring machine receives its official inspection at the factory. This machine will drive the southern section of the crossing. Comprehensive fire safety systems and evacuation procedures have been tested many times. The tunnel is designed to handle emergencies safely. The overhead power supply is energized for the first time. The entire electrical system must be thoroughly tested before passenger services begin. Environmental monitoring continues throughout construction to protect the sensitive marine ecosystem of the Bohai Sea. When the two tunnel drives finally connected, it marked one of the greatest engineering achievements in Chinese history. The tunnel's ventilation system has been designed to quickly remove smoke in case of fire. Full-scale tests confirm its effectiveness. Special measurement trains check the geometry and quality of the new railway track. Every section must meet strict high-speed rail standards.
The main bearing seal system, is it the same configuration? We had tremendous problems with slurry ingress or our main bearing on the soft ground machine.
It's pressure grease between stages, same principle, larger scale.
Workers who enter high-pressure zones must undergo controlled decompression afterwards. Medical teams carefully manage this critical safety process.
40 minutes remaining.
The southern portal has been designed as a striking architectural landmark. It marks the entrance to one of the world's greatest engineering achievements. The tunnel will transform travel between Dalian and Yantai. What once took many hours will soon take less than an hour by high-speed train. A dedicated control center monitors the tunnel around the clock. Every train movement, ventilation system, and safety sensor is watched continuously. Once the tunnel boring machine has completed its drive, the launch shaft is carefully backfilled. The focus now shifts to finishing and commissioning. When it opens, this tunnel will hold the record for the longest undersea railway section ever built. The first commercial high-speed train departs on its inaugural journey through the tunnel. This moment marks the beginning of a new era of connectivity. Passengers traveling through the tunnel will be more than 80 meters below the seabed. The journey will feel smooth and comfortable despite the depth. The tunnel has been designed to withstand seismic activity from nearby fault zones. Continuous monitoring ensures structural safety at all times. A constant supply of materials and workers is transported deep into the tunnel by rail. This logistics chain keeps the project moving forward. Detailed economic studies show that the tunnel will bring major long-term benefits to both regions through faster travel and increased trade. The installation of the final tunnel lining ring marks the end of the main civil engineering works. After completing its long drive, the tunnel boring machine is carefully dismantled. Valuable components are recovered while the shield remains in place. The new tunnel connects directly into China's national high-speed rail network. Trains can now travel seamlessly between the north and south. During construction, historical artifacts from ancient maritime activity were discovered in the seabed. These findings add to our understanding of the region's past. Thousands of skilled workers from across China have contributed to this project. Their combined effort has made this engineering marvel possible. The official opening of the Bohai Strait Tunnel represents a major milestone in China's infrastructure development. The successful completion of this project now makes other challenging undersea connections technically feasible in the future. Land created from tunnel spoil is being restored into valuable coastal habitat. Nature is gradually returning to the reclaimed shoreline. Beneath the waters of the Bohai Strait now lies the world's longest undersea railway tunnel, a testament to human engineering ambition and achievement.